Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, let me introduce myself. My name is Anuska Putri. I represent my group, such group 3 Olympus. Next, as you know, Indonesia has an archipelagic country and has a considerable potential for oil reserve to be explored. The main activity of the offshore building industry is fabrication in support of the oil gas and sector in Indonesia, and the development of the offshore building industry is also to increase the capability of national maritime industry. Next, based on that, we propose a title such as corrosion aspect analysis of offshore structure and its effect on durability of stainless steel material. Next, we have 10 members such as Ahmad Yazid, Angelica, Farel Afif, Gian Anaresika, Lucinawang, Muhammad Raihan, Pradip Tadwi, Ralif Yoga, and the last one is Raihan Gali.
Okay, what are we going to talk about? The first one is introduction, and then offshore structural infrastructure materials, and the next one is methodology, and the last one is conclusion. Next. Okay, first of all, the director of the Maritime, Aerospace and Defense Equipment Industry, or IMCAP, of the Ministry of Industry, SB Asidik Shamsuddin, said that the increase in world oil prices had also boosted the growth of the offshore building industry. Next. Okay, in 1964 to 1965, American oilmen had tried their luck in Indonesia, but they are unsuccessful to obtain a contract to a search area northwest of Java for offshore oil. And then in the early 1966, they finally got the contract after negotiating with the government and signed a production sharing agreement with Permina. The company that first on the offshore scene in Indonesia was Independent Indonesian American Oil Company, IIAPCO. And then in 1977, Indonesia produced around 2.8% of the total world oil output of 22,610 million barrels. Next.
Building resistance. Bricks have an average age of 22 years. As claimed by the Offshore, sanitary discharge system comes in two stainless steel grades, IC 316L and IC 300 form. What is the types of material commonly used for offshore structure infrastructure? First, flat-wick steel. Flat-wick steel is increasingly being used because of the increasing need for steel material that is lighter, strong, more economic, more durable, and easier to use. The profile formation can be carried out using a cold forming process because the dimension of the thickness of the profile are relatively thin. In this process, the profile is formed from a steel plate or sheet into the desired shape V rolls or a plate bending machine at room temperature. Then stainless steel. Stainless steel is alloy steel with high alloy steel and special properties that are resistant to corrosion and high temperatures. Stainless steel has a chromium content of approximately 10.5%. This content protects the steel from the corrosion process that occurs. Chromium is the result of the oxidation of oxygen to chromium, which is formed spontaneously. This substance blocks the oxidation process of iron. Stainless steel has many advantages, namely sufficient torque and cutting properties. There are four main types of stainless steel, namely austenitic, ferritic, martensitic, and duplex. Next.
there is difference between lightweight steel and stainless steel. The first one is lightweight steel doesn't resist to corrosion, while stainless steel resists to corrosion. Lightweight steel contains about 98% of iron, and stainless steel contains about 90% of iron. Lightweight steel have high weldability and high and good ductility, while stainless steel have low weldability and bad ductility. The price of lightweight steel is more affordable than stainless steel, while the price of stainless steel is cheaper than lightweight steel. Next.
So basically in this research, to extend the offshore structure corrosion aspects and effects, qualitative method is used by taking literature review from reliable sources. This literature review is a part of interactive model data analysis technique.
Data analysis and results. An offshore environment is where the pipe experiences a humid and salt-containing environment. With the salt containing mainly of chloride ions, the humidity and chloride content is depend on the location of the pipe and condition during the installation. These conditions are the water, testing of the luge system, and washing of the plant with seawater.
To minimize the risk of material failure at an acceptable cost, the term cost also includes maintenance costs in the total design life of the structure. Several materials are used in an offshore environment, like carbon steel, copper, titanium, and nickel alloys, and stainless steel, where AISI 316 or 316L is austenitic stainless steel.
These two and other stainless steels are much used owing to reasonable cost and accessibility for piping, which experience dynamic or flow condition. The 316 alloys are the most reliable for corrosion resistance and are therefore often used in an offshore environment. Next.
The specification for composition of AISI 316 and 316L. The susceptibility to pitting and crevice corrosion of the stainless steel provide the reason for trying to find another steel type. Knee-based alloy were tried, but they are very expensive with severely limited use. The alloy have a high corrosion content and content more for corrosion protection. From 1960 onward, stainless steel with 6% more were used to prevent localized corrosion, called high alloy stainless steel.
So what is the conclusions? First, stainless steel material is more worth for use in offshore structure. Second is comparisons of other offshore materials. The third, the search of stainless steel for the material used in offshore structure. And last, the benefit of the AISI 3016 or 316L for use in offshore structure and minimize the corrosions. So I think that is all enough from our group 3 Olympus. Thank you.